So in the last class, we have completed basically elimination reaction, right? Do you have any doubt from the elimination reaction?
No, sir.
Okay. So now we are going to study the next chemical reaction, that is next chemical reaction of haloalkane. Okay, and that is the third reaction properties or chemical properties of the haloalkane, and it is basically reaction with metals. And in this part we need to study two reactions. Hold a minute, please. So see, Aman, basically this is about the reaction with metals. And in this part, the first is Grignard reagent. Grignard reagent. And what does this Grignard reagent means? So basically Grignard reagent is RMGH. And how does it form? And what is the general chemical name of this compound? So basically when an alkyl halide like CH3, CH2Br react with magnesium, it will form CH3, CH2, MgBr, CH3, CH2, MgBr, and this is called basically Grignard reagent. Grignard reagent. Also, the compound is known as organometallic compound. Also, the compound is known as organometallic compound. Organometallic compound, and this compound is very reactive. This compound is very reactive, and the bond between carbon and metal is covalent, and the bond between this metal and bromine or halogen is ionic. Are you getting my point?
Yes, sir.
So basically this is a very important compound that is known as organometallic compound. Organometallic compound, that means basically bond between carbon and metal. This is organometallic compound. And if there is Br, you can see the bond between this is covalent, and bond between these two will be ionic. And this is very reactive. Even if there is a moisture, they will easily or they will react with that moisture and forms alkane hydrocarbon. So I can write a point. Grignard reagent are very reactive and react with moisture, moisture from surrounding, or we can write it can react with any source of proton beam, any source of proton to give hydrocarbon, to give hydrocarbon. Please write up to this, then I will explain the reaction. Even it reacts with the moisture to form hydrocarbon. Let me know when you're done with this.
Yes, sir. Done.
Very good. So now you can see I'm going to give you the reaction. First of all, we are going to discuss about this RMGX. So RMGX. As you know that this metal is electropositive in nature, and metal is also called electropositive element because it can easily donate its electron, or we can compare by their electronegativity. Since non-metal are more electronegative and very less reactive, metal is, or we can say electropositive, so it will have delta positive and it will have delta negative, and this will have also delta negative charge. That's why they are very reactive. Now, when it comes in contact with any source of proton, it just react as fast as it can to form hydrocarbon. And you can know, you know what the product will be. The product will be hydrocarbon along with Mg, OH, and X. How does I write this reaction? It's very important to know. As you know that this RMGX, as we know that this will have negative charge, this will have positive charge. Now, this H2O, can I write this H2O as H plus and OH minus? Just suppose this is a moisture which contains proton. Proton, that means H plus. What does this proton means? H plus.
Yes, sir.
So you can see what you need to do is, as you know that the nature, positive will go to negative and negative will go to positive. So you can see this H2 is dissociated into H plus OH minus, and H plus will go to R. So it will form RH, alkyl group with H forms hydrocarbon, that is alkane, and this will be Mg and then OH and then X was there. So X will also be there. Mg has plus 2 charge. So OH has -1 and X has also -1 charge, so it just neutralizes. Again, if I'm going to take an example, another example like CH3, MgBr, and you are going to react this with H2O. So what will be the product? You can see this will have positive charge, this will have negative charge. Now this H2O part, H plus and OH minus. So this positive will move to this negative and this negative will move to this positive. So now CH3, if goes, this H plus will go to CH3 minus, it will form CH4, and there will be a byproduct, that is MgOH. Got it?
Yes, sir. I understand.
Please do it and let. So if there is any alkyl halide, you need to react this with magnesium to form Grignard reagent, and then followed by hydrolysis, then you will get your alkane. Are you done with this?
No, sir, not yet.
Okay. Oh, sorry.
Yes, sir. Done.
Okay, reaction can be given like this: CH3, CH2, CH2, and then CH2. Reacting with magnesium will give, and also the reaction will carry out in dry ether, in the presence of dry ether, because it is very reactive. So it will form A, and then followed by hydrolysis, A will be reacting with H2O, then form B. So what will be the product? You know that whenever an alkane reacting with magnesium, so it will form, sorry, not only with magnesium, alkane. So there is an alkyl halide reacting with magnesium. So what will be the product? CH3, CH2, CH2, and then MgBr will form. And now, if it is goes through H2O, that means H plus and OH minus. And you also know that you have to do it in mind. This is positive, this is negative. So this positive will go to this, and this negative will go to this. So what it will form? Propane. So if there is any question, and the byproduct will be MgOHBr. So if there will be any question like there will be conversion, like if you need to make one bromo propane to propane, if there will be a question like convert one bromo propane to propane, so this is the way you are going to make it. So you can see this is are basically one bromo propane, and this is basically our propane. So we can easily convert with this method. Let me know when you are done with this. Are you done with this?
No, sir.
Okay.
Yes, sir. Done.
Very good. So now I'm going to give you two type. There are two questions on this. I'm going to give you. So there is CH3, there is CH3, and then there is CH3, and this is associated with bromine. And you are going to react this with magnesium. Magnesium. Then let again be hydrolysis in the presence of dry ether. Just let me know the A, and then followed by hydrolysis. and let me know the B. Again, same thing. D2 followed by D. Please let me know the name of the product. Are you done with the first one?
No, sir, I'm still doing it.
The first one is still doing or done?
I'm still doing it, sir.
Okay. So let me know if you have any doubt or if you are unable to solve it.
Sir, can you solve the first one?
So you can see what happens here. Magnesium will go between carbon and bromine. So what will be the product? CH3C MgBr. Yes or no?
Yes.
Now, can you do the rest part, the B? Yes or no? Please let me know. Or you need H1. So H2O is H plus and H minus. Now you know that magnesium is less electronegative, electropositive, so it will have positive charge, and carbon is non-metal, more reactive, more electronegative. So this will come here. So after this, we will get CH3, C, CH3, and with C there will be H, and the byproduct will be Mg, and then OH will come between Mg and Br. This will be the byproduct.
Okay, sir, I understand.
Okay. Can you
I'll
do
do
the
the
next
second
one?
one.
Okay.
Yes, sir.
Okay. Thank you. Are you done with the product A?
No, sir. I'm doing the second product B.
Okay, that means you have already done A.
Yes, sir.
So is that you got? Yes or no?
Yes, sir. That's what I got. Same.
Okay. So do you know what does this D2O means?
Sir, it's heavy H2O.
Hard water. We can say it. These
Yes.
isotopes of hydrogen. So this will be again converted in the same way. D plus and OD minus. In the same way as H2O dissociates H plus and OH minus. Yes or no?
Yes, sir.
So this will come here. So the product will be CH3, C, then D, then CH3, and then here CH3 will be, and then there will be another other the byproduct OD and Br. Please let me know when you are done with this. Are you done with this?
Yes, sir. Done.
Very good. So you can see that the next part of this reaction with metal is known as Wood's reaction. Wood's reaction. So basically, when alkyl halide react with sodium in the presence of dry ether, then this reaction is called Wood's reaction. And whatever is the number of carbon present in alkyl halide will be double in the product. What I want to say is that I'm first going to write a point about this. Alkyl halides react with sodium in dry ethers to give hydrocarbons containing double the number of carbon atoms present in the halide. Got it? This reaction is known as Wood's reaction. This reaction is known as Wood's reaction. So what is the reaction? Basically, there is first I'm going to write a general reaction like 2 moles of RH reacting with 2 moles of Na. Then it will give RR and then 2NaX. How does this reaction takes place? I'm going to explain. So if you have RH 2 times, that means 2 moles, and 2Na, I'm going to write it like this. And now another mole of Rx. I'm going to write it in opposite to understand it. And what you need to do is just eliminate this and connect this. So it will be RR and now NaX, that means 2NaX. Got it?
Yes, sir.
Please write it. And also write in presence of dry. Please write the name of the product. Are you done with the question?
No, sir. I'm writing the question.
Okay.
So I'm done with the first one.
First one. So how many carbons are present here? You can see two carbons, so it will be double of this alkane there will be. So it will be butane. Yes or no?
Yes, sir.
So what about the next one? And as a byproduct, you will get NABR.
Yes, yes, sir.
Very good. So it's not necessary that it will be written to here also. It will be, or it may be, or it may not be. So you have to understand with this alkyl halide with sodium in the presence of dry ether is called Wood's reaction. Are you getting my point? So in the same way, this is 3 carbons, so it will be doubled. So 6 carbon alkane, that means hexane, CH2, then CH2. You just need to write the mirror image of that. This is yes or no?
Yes, sir.
So please complete this and let me know. Then I'm going to start the reactions of haloarenes.
So the byproduct will be 2 NABR, right?
NABR, yes, that is constant.
Yes, sir. Done.
Okay. Now going to start this reaction of haloarenes. To see what is this reaction of haloarenes. So basically, there is a reaction in this nucleophilic substitution. And you know what? This haloarenes is extremely less reactive towards nucleophilic substitution reaction because it is already very stable due to resonance. And there are a lot of other reasons that we are going to discuss. So now see, I'm going to write a point which is very important towards this. Aryl halides. Do you know what does this aryl halide means? There will be a halogen connected with benzene that is called aryl halides. This is common name. Aryl halides are extremely less reactive. Aryl halides are extremely less reactive towards nucleophilic substitution reactions due to following reasons. Due to following reasons. So the first reason is basically a resonance effect. A resonance effect. As you know that a resonance stabilizes molecules very much. So the first reason is the resonance effect, and I want you to do write the resonating structure of this chlorobenzene. I want you to do this. Can you do it? The resonating structure.
Okay, sir.
Let me know when you are done.
Yes, I'm done.
Very good. So what you just did, you just move this pi electron to here and this to here. So what you get, there will be negative charge, double bond, and there will be double bond, and there will be positive charge. Again, move this to here and this to here. So now you can see there will be negative charge, and the double bond will be. Oh, wait a minute, not negative charge, not here. Negative charge now will be here, and the double bond will move here. Now again you can see this bond will move here, this pi electron, and there will be negative charge here. Double bond, double bond, double bond, positive, Cl positive. And again you can see. So this is the resonating structure, yes or no?
Yes, sir. That's what I drew.
Yes. Did you get the same?
Yes, sir.
Oh, very good. So basically, this aryl halide is very stable. That's why it is very extremely less reactive towards nucleophilic substitution reaction. The first reason is basically a resonance effect, and the second reason is difference in hybridization. Difference in hybridization. So you can see hybridization. So basically you can see if you have an aryl halide like this, and if you have an alkyl halide like this. So can you tell me the hybridization of this carbon and this carbon? Can you tell me?
So for the first one, it's sp2.
It's sp2, and what about this? It
So,
is
sp3.
So you also know that S character increases, electronegativity increases. Yes or no?
Yes, sir.
Do you know about it? If you don't know, please remember that S character increases, electronegativity increases. And as you know that this is sp, this is sp2, this is sp3. Now you can think of like business. There are two business partners. What will be the contribution of each? 50% generally. Am I audible?
Yes, sir, you are.
So what I am asking is, there are two business partners. Each has 50%. So
Yes.
S character here 50%, and you can see there are 3%. Three persons are there, and equally. So S characteristic 33.33%, and here it will be 25%. Yes or no?
Yes, sir.
So if it is the more S character, the more electronegative. So you can see here it is sp3, that means less electronegative, and this is more electronegative. And due to the more electronegative, the bond will be more polar. So if there will be more polarity, so that's why it will be difficult to break that bond. Are you getting my point?
Yes, sir.
Okay. So this is the second reason for very less reactive towards nucleophilic substitution reaction. Now there will be another reason. First write this. Are you done with this? Are you done with this?
Yes,
The
sir.
above one. Now
Yes, sir.
see the third reason you can see. The third reason is basically instability of phenyl. Oh, wait a minute, it's not. Okay. The third reason is instability of phenyl cation. So you can see that if you have an aryl halide and if chlorine will go, there will be positive charge on this. Yes or no? So this is very unstable, very unstable, which does not allow for nucleophilic substitution reaction. Are you getting my point?
Yes, sir.
So please write these three. Let me know when you are done with this. In the next class, I'm going to take your test. Okay. For half an hour only.
Sir, for which topic?
This chapter, basically,
Okay.
not whole, up to this, from this chapter up to this today's topic.
Yes, sir, I'm done.
Very good. Now we are going to see the chemical reaction of this nucleophilic substitution reaction, since it is very, very less reactive towards nucleophilic substitution reaction. The condition for reaction will be very drastic. So the first is basically a replacement by hydroxyl group. Replacement by hydroxyl group. So basically, chlorobenzene, we are going to react this with chlorobenzene, can be converted into phenol by heating in aqueous sodium hydroxide, aqueous sodium hydroxide solution at a temperature of 623 Kelvin and a pressure of 300 atmosphere. 300 atmospheres. So basically, the condition you can see is very high, like very high temperature and very high pressure. Then the reaction will go forward. So this is our chlorobenzene, and you can see if you are going to react this in the presence of alkali NaOH at 623 Kelvin and 300 atm pressure, followed by acidification, that means H plus, then only you will be able to get phenol. This, please write. After this NaOH, you are going to do this H plus, then you will be T. Let me know when you are done. Let me know when you are done with this. Ayman, are you done with this?
No, sir. I'm just drawing
Okay.
the figure.
Okay. The condition you can look at is 623 Kelvin, very high temperature and very high pressure.
Yes, sir, I'm done now.
Now see, this chlorobenzene alone is very stable. That's why it is very less reactive towards nucleophilic substitution reaction. Now the next point about this reaction, if you are going to add NO to this NO2 to this group, this NO2 is basically electron withdrawing group, which make this compound more reactive than earlier. So the condition will be slightly lesser. Now I'm going to write a point about this. The presence of an electron withdrawing group, the presence of an electron withdrawing group, that is NO2 at ortho and para positions, at ortho and para positions, increases the reactivity of increases the reactivity of haloarenes. It increases the reactivity of alkyl halides or haloarenes. So you can see this is our chlorobenzene in which I'm going to add NO2 para position. So the condition you can see NaOH was there, but the temperature is 443 Kelvin, very less temperature than earlier, followed by acidification, that is H plus. So you will get a product phenol. Cl will be replaced by OH and NO2 will be there. Now again you can see if you are going to add one more, if you are going to add one more NO2 to this, this is Cl and ortho at ortho and at para with respect to Cl. The condition will be now again very low, like NaOH, 368 Kelvin, followed by acidification, that is H plus. So the product will be, you can see OH, Cl will be replaced by OH and NO2 was at ortho with respect to Cl. And so you can see if electron withdrawing group added to this chlorobenzene, then this increases the reactivity of haloarenes, and that's why the condition decreases. Please write it. Let me know when you're done with this.
Yes, Ramda.
Very good. Now you can see if you added 2NO2, this was the NaOH and 368 Kelvin. And if you are going to add 3NO2 to this group, like this is OH, this is NO2, this is also NO2. Now this will be very, very reactive. And if you are going to just put this in warm water, then sorry, this is not OH, this is Cl, chlorobenzene. This Cl will be easily replaced by OH. Please do this. Then I'm going to give you some questions. And in the next class, we are going to complete this chapter.
Yes, Ramda.
Very good. Now I'm going to give you a question. It is related to basically SN1 and SN2, which is very important for this chapter. In this chapter, in the following pairs of halogen compounds, which compound undergoes faster SN1 reacts?
Sir, the first one.
In the first one. Why? In SN1 reaction, we know that 3 degree, 2 degree, 1 degree, right?
Yes, sir.
So this is the answer. What about the second one? What about the third one? First tell me.
Sir, what's that letter? I don't understand it.
The third one,
Yes, sir.
you can see both are 1 degree, 1 degree. So we will
Yes.
go for best living group. Iodine best living group, then bromine, then fluorine, then fluorine. So it will be iodine will be this alkyl halide will be more reactive. Okay,
Okay,
is
sir.
that clear? Now, can you tell me about the second one?
Sir, the first one will go far.
First
No,
one.
sorry. Yes,
Yes,
first
see,
one.
what happens here in SN1, there will be formation of carbocation, yes or no? And both
Yes,
are
sir.
2 degree, both are 2 degree. And there is support from here and here, and there is support from here, here, and you can see this will increase its support more than this. That's why the first one. Is that clear?
Yes, sir.
So this is it for today. If you have any doubt, please ask me. Otherwise, I will continue. I'll complete this chapter in the next class, and we will have questions and then